Hola clase. In this video we are going to see how to solve by elimination or the elimination method. Remember at all points or at all times what you are searching for. The point that makes true both equations at the same time. The objective in the elimination method is to eliminate one of the variables, that's what's called elimination, to then solve the other. Remember, I can only save one variable at a time, and for that I can only work with one equation at a time. It's very suited to systems that already have the tidy equations, and by that I mean the x's are in the same place, the y's are in the same place, and the constants are in the same place. Or if I've got something where one of the variables has in both equations give me the same coefficient or proportional coefficients. So if you have something like that, for example, everything is tidy, the y's are with the y's, the x's are with the x's, the constants are with the constants, everything in the same order, and I see here the exact same coefficient with opposite signs. So this could be an ideal case for use this method, elimination method. Most of the time it's going to look something like that. I'm going to have to do some adjustment. So what is the process? Every time that I want to use this method, first I'm going to tidy my equations so they look like that. Ax plus by equals k. And I'm going to use the same in both equations so things are tidy by columns. Then I may need to adjust the coefficients. Have a look here. I don't have any coefficients that much. I'm going to have to force them. These two parts may be already done for me. Then I decide which variable to eliminate, for example x, and I'm going to eliminate it by adding or subtracting those equations together, whichever is more convenient. After that, I will have one equation with one variable. I can solve that. That's basic algebra, like I've done millions of times. Once I've got that, I work backwards to solve the variable I eliminated before. And at the end, important, I tidy everything together. I don't want to be searching for the solutions halfway through my solutions or my working, but I want them easy to find. I put them at the end in a box. So we're going to do this example here because it's the one in which we will have to do everything. So first of all, let's make sure things are tidy. Actually, I'm going to go here because we're going to need it later. For space's sake. Alright. Now, I don't have coefficients that much. That means that I'm going to have to do something with them. So I can remember what do I do. I'm going to label the equations. Okay? So, if let's say that I want to eliminate the x's, best thing you can do if you want to use this method, have a system, eliminate always the same variable unless there's one that is obviously easier than the other, and that way it will always work for you. So if I see a 3 here, I could need a 3 there. So the first equation, I'm going to leave it like it is, 3x plus y equals 3, but then what could I need to do to the second equation to have a 3x there? I could have 2 multiplied times 3. If I multiply this x here, I have to multiply the minus 2y here, and I have to multiply the constant, okay? So x times 3, 3x, minus 2y times 3, minus 6y, and 8 times 3, 24. And then what I'm going to do, I'm going to subtract these two equations. So I'm eliminating one variable by adding or subtracting. I'm subtracting because I've got a 3 and a 3, so if I subtract, this cancels. Now 1y minus 6y, that's 7y, equals 3 minus 24, that's minus 21. And then this in here where I can solve this variable. I've got one linear equation with one variable. Okay, y, this 7 will pass here dividing, minus 21 divided by 7. With practice you wouldn't need to write this, but that would give me minus 3. Perfect. Now I've got 1 out of 2 variables. Remember, I'm searching for a point. I need 2 coordinates. So now I'm going to work backwards, and I can use any of these 2. In this one, x doesn't have any coefficients, so it's going to be easier. Okay, so if x minus 2y equals 8, now what I'm going to do, I'm going to substitute this minus 3 where the y is going, because I already have the value there. So what I would have would be x minus 2 times minus 3 equals 8. And again, not that you would need to write it, but just so you know what we did. We put this minus 3 in lieu of the y that was representing. Okay, x minus 2 times minus 3 is plus 6 equals 8. This would pass subtracting, x equals 2. Now I've got both variables. I've got my y here and my x here. My very last point. Tidy things so I don't have to be searching for them later. So at the very end, x equals 2, this one here, y equals minus 3. And that is telling me that for these 2 equations, the point where both of them are true, the point that cuts, is this one. The point would be 2 minus 3 as my solution. And that, following this method by elimination, the coefficients may vary, but I'm always going to have an x, a y, and a constant, which means I will always be able to follow it and give a solution. Thanks for watching.